right, we are moving on to some important characteristics of functions and their graph. So what we are going to do is look at some things that you might already be familiar with, some things that might be new to you, and then we are going to later on go and apply it to any kind of function. You should be able to tell me these different characteristics that they have. So we are going to start with intercepts. We can have an x-intercept, points where it crosses the x-axis, and at all of these points our y-coordinate is 0. We can also have y-intercepts where our graph crosses the x-axis, the y-axis, and our x-coordinate is 0. So we've got this nice, lovely graph here that kind of bounces. Where are the x-intercepts located? So my x-intercepts are going to be everywhere that I cross the x-axis, and that happens here at 1, 2, 3 places. So it can be in more than one place. So let's talk about those coordinates. I've got here -1, 0, 4, 0, and 8, 0. Notice all of those y coordinates are 0, and so I have multiple x-intercepts. Now if I want to find my y-intercepts, again, I'm just going to look where my graph crosses the y-axis, and that is in this one place here. We're going to call that about 0, 2-ish, and it only happens in one place. And let's think about why that is for a minute with what we already know about functions. So my x-coordinate is 0 every time I have a y-intercept. And my x's cannot repeat. So you're only ever going to have up to one y-intercept when we're graphing a function, but you could have multiple x-intercepts because y's can repeat. Moving on, we are going to look at increasing and decreasing. This has to do with my graph's shape. So if you imagine a person is walking on your graph from left to right, if that person was going to be walking uphill, that would be increasing. If the person was going to be walking downhill, the graph would be decreasing. Now we describe these sections in intervals, so interval notation, and you describe over what x-coordinates this is happening. Again, we're going from left to right. Left to right is our x-axis. So at those boundaries where we're switching from increasing to decreasing, we are going to be using parentheses because at that change we say it's neither increasing or decreasing, it's a boundary. And then we also use parentheses when we don't know the behavior before or after a certain point. So looking at this graph here, you've got this nice visual of your person going from left to right. They start walking uphill, so increasing, then it goes to downhill, decreasing, and then it becomes uphill again, and that arrow means it's going on forever. So over what intervals is my graph increasing? Where am I walking uphill? Well, that's from this start until this point here at 2 where it switches, and then it picks up again here at 6 and goes on forever. So I've got 2 intervals, and again I'm describing the x-coordinates over which that is happening. So I'm starting here at 0 and it goes until 2, that change point. Now the 0, because I don't know what's going on before that, is going to get a parentheses. And the 2, that's a point of change, so it also gets a parentheses. Now it picks up again at 6, and that is a point of change, so it gets a parentheses. And it's going on forever to infinity. And infinity always gets parentheses. I've got my 2 intervals, so I connect them with a union. So now, where is my graph decreasing? That is going to be this in-between portion. And the x-coordinates are from 2 to 6. Both get a parentheses because those are both points of change, so it's neither increasing or decreasing. So now you know about x and y intercepts, you know about increasing or decreasing, and you should already be familiar with domain and range. So we are briefly going to go into a little function recap while I've got you here, evaluating some functions. Remember, if you're given the input, you're just going to plug that into your function. So on this first one, that would be 2 times -2 minus 3. So -7 is your final answer. On the next one, it's going to be 4 minus 1, which is +3. On this one, g of -3 minus f of -1. I already know this is 3, but first I want to find capital G of -3, which I have to plug in here. So 9 minus 6 minus 7 is -4. So I've got -4 minus 3, which becomes -7 as the final answer. And then f of x minus 2, I'm plugging in the expression, and I'm going to use order of operations. And all I can do is combine like terms. So x stays as part of the answer. Now this next one, again, we did do this previously as well, but what happens when I'm plugging in an expression and I have to square it? Remember, that means you are FOILing. So that is just a quick recap of that. We're going to do one example. So f of 2x plus 5 is going to look like 2x plus 5 squared minus 3 times 2x plus 5. So this means I'm FOILing. I'm going to get 4x squared plus 20x plus 25. Then I have to distribute the 3, -6x minus 15. Now I can combine like terms. 4x squared plus 14x plus 10 is the final result.